It's working. We are going to look at higher derivatives. The second derivative, the third derivative, the fourth derivative, the nth derivative. So some notation. The first derivative has one little dash mark. The second derivative has two little dash marks. F double prime, y double prime. And in Leibniz notation, it gets a little wacky here because it's d2y over dx squared. So we wonder, why aren't the squareds at the same place? Well, part of the reason is when you take the derivative of something, we've seen this notation. Take the derivative once. If you would take the derivative again, that would be taking the derivative twice. So technically, this is your function, this is y. So across the top, you're taking the derivative twice of y with respect to x. And I guess mathematically, mathematicians probably should have had brackets on the bottom to put squared, so you don't think it's just the x squared, but I guess they were lazy here and said, we'll just write the squared. And everybody will agree it's okay. So to find the second derivative, you find the first derivative, and then you just find the derivative again. Yes? I spelt it wrong? Oh, nice. Did I write it? Is it corrected here? Oh, I corrected it here, but I didn't correct it in your notes. It's good. Excellent. To find the second derivative, you find the first derivative first, and then find the second derivative after. And the third derivative would be just finding the next derivative. So what does this mean? You have your first derivative. F of x equals x cubed minus 5x. We could rewrite this in a more friendly way. Your first derivative would be take the 3 out in front, subtract 1 from the exponent, bring the negative 1 out in front, subtract 1 from the exponent. That would be our first derivative. Then our second derivative bring the negative 2 out, subtract 1 from the exponent. Could you keep on going? Yes. Right? Would you like it if I asked you to find the 15th derivative? Wouldn't be too bad. Could figure out a pattern of what's happening. Right? What's going to happen next to this one? Third derivative, this would just be 6. Fourth derivative, this one's going to be 0. And then that one's gone. So you just have something left with that one. Now, sometimes when you're asked to find the second derivative, things get more complicated after you do the first derivative. So first of all, if we were doing the first derivative here, dy dx, how would you do that? Would we have to use any of our special rules? Which rule would we need? The chain rule. So here, the 3 would come out in front, keep the inside the same, subtract 1 from the exponent, then multiply by the inside. And now, if I wanted to use that to find my second derivative, what rules would I have to use? Would I have to use chain rule again? Yes. And product rule. Can you see that I have two things multiplied here? And so the product rule says keep one the same. So I'll keep this one the same. Multiply by the derivative of the second one. Plus, keep the second one the same. Multiply by the derivative of the first one. And the first one would be a chain rule, so the 2 comes out in front. Keep the inside the same. Subtract 1 from the exponent. Multiply by the derivative of the inside. That's a 2x minus 3. So you can see why some of these derivatives get really, really, really long. So sometimes in situations like this, somebody might say, maybe I would like to simplify first and then do the derivative. Okay? So if you multiplied this out, can you see that this would be x squared cubed plus 3x squared squared minus 3x plus 3x squared minus 3x squared plus minus 3x cubed. So I just multiplied that out using the binomial theorem. And then I could simplify this to be x to the 6th minus 9x to the 5 minus 9. No, wait for it. This should be in brackets, right? Minus 27. No, plus 27 x to the 4 minus 27 x cubed. Had I multiplied that all out to begin with, then my first derivative is really easy, just power rules. My second derivative would be really easy, just power rules. My third derivative, really easy, just power rules. And it could make my life easier if I had to do a lot of them. So sometimes we have to make that decision. Do I want to expand something? Will that save me time? Or do I want to just use the chain rule and the product rule? Because right now, if I had to do a third derivative of this, here, it would be really straightforward. It's just a chain rule in my first term. But my second term would be a product rule and a chain rule again. And even it might have a product rule within a product rule, which I'll show you after we get some more complicated functions. We'll add some longer derivatives to see what they look like. All right, so that is all for second and third derivatives.